Hello and welcome to the last video in this series on the binomial expansion, and we're going to continue with where we left off in the last video with looking at the binomial distribution. So we're back to looking at Appleseed and Lucinda. Still planting 40. This time this variety has a different probability of germinating at 0.16. So the first part of this says to model the situation as a binomial distribution. So we can look at this in much the same way as we did with the last video. So we can say that our distribution x is a binomial distribution and the parameters are 40, 0.16, which is the number of trials and the probability of a successful trial. But this time it says find the probability that no more than, than 2 of the seeds germinate. So we're going to look for the probability that x is less than or equal to 2. So that's no more than 2, so 0, 1 or 2. So we're not just looking for a single term this time. So what we're going to have to do here is we're going to have to use the binomial expansion with but more than one term. So if I want to look at there being 0 that germinate, so that's 40C0, and then 0.16 to the power of 0, so that's 0 germinating, and therefore 40 not germinating. And I'm going to have to add to that 40C1, 0.16 to the power of 1, 0.84 to the power of 39. So that's looking at the number of combinations that 1 will germinate, and then multiplying that by the probability that 1 germinates and that 39 do not germinate. And then my final term here is going to be 40C2. So this is looking now at 2 germinating, so that's 0.16 to the power of 2 and 0.84 to the power of 38. So it could take quite a bit of effort to type all these up. Now you may have a calculator with a distributions function. If it does, then you want to go down to where it says binomial CD. So the CD is for the cumulative distribution, and this is cumulative because we are working up from the beginning. And this will let you put in the parameters for x, n and p, where in this case x would be 2, n would be 40, and p would be 0.16. And when I do that, it gives me the answer of 0.03455 if I go for 4 significant figures. And there we go, there's our probability that 0, 1 or 2 germinate. So when we look at these questions, be slightly careful about the inequalities. So remember, x is less than 2 means it could be 0 or 1. X is less than or equal to 2 would include the 2 as well. So be careful about that here. Also be aware that if you have a very large number of terms you need to include, instead of looking at the cumulative for the number of successes, sometimes it's easier to turn it on its head and think about the number of fails instead. So for instance, in question A there, we're looking only for x being less than 2. If that was x was greater than 2 instead, you'd be doing all the terms from x is 3 up to x is 20. So in that case, it would be easier to work out x is 0, 1 and 2 and then subtract that probability from 1. So the first 4 are written in statistical notation, so it should be relatively straightforward to get going with. E and F, you're going to have to model it first. And then here come the answers. Okay, and that concludes this series of videos on the binomial expansion.